countless and beautiful marine fisheries resources. In the shallow waters of the sea, seaweeds or halamang dagat are among our important marine resources. The brown seaweeds known as Sargassum seaweeds comprise the big bulk of the marine algal flora, which are common along the Philippine shores. They are usually swept by waves during high tide and eventually left as wastes to rot. In an effort to tap the potentials of Sargassum seaweeds, researchers are being initiated to help maximize its possible application in various industries. The Philippine Council for Industry and Energy Research and Development, or PISHERD, an agency of the Department of Science and Technology, has granted financial assistance to a research project on seaweed production and processing. At the helm of the research study on Sargassum seaweeds, financed by PISHERD, is the Marine Science Institute of the University of the Philippines, in cooperation with the Philippine Textile Research Institute of the Department of Science and Technology. In 1992, the joint research project started. The focus of the study was on alginate, an extract from brown seaweeds.
The main funding agency here for the project is PISHER, that's Philippine Council for Industry, Energy, Research and Development. But I have a partner in this research, the one which does the applications is the PTRI, that's Philippine Textile Research Institute, and the institute here, Marine Science Institute, where we do the extraction and study the pilot plant scale. Somehow along the way, we also have there are contributing projects to the project. Like for example, PICAMARD, that's the Philippine Council for Aquatic and Marine Research and Development, has funded a study for Dr. Trono about the distribution of the brown seaweeds in the Philippines. And also they funded the screening. There's a large number of researchers all over the country who would screen for alginates in Philippine seaweeds. So there's a number. Basically, the funding comes from DOST. Objectives of the project is really to study the production in pilot plant scale. You see, it's very nice when you have, even now, you have laboratory scale, you have very good yields and very good quality, but when you scale it up, there are always problems. So that is the main objective is to study the production in pilot plant scale. Another objective is to produce, see whether we could produce low viscosity alginate, medium scale viscosity alginate, and high viscosity alginate. You see, traditionally we've been told in the literature that we cannot produce medium or high viscosity alginates from Philippine brown seaweeds, but with our laboratory results, it indicates that we could. So that is what we want to do, is verify it in a larger scale. Then the next part of the project is to do the applications for the textile. Basically, why basically textile? Because 60% of our imports on alginates goes to the textile industry. And fourth is to do the economic studies feasibility and whether this technology could be transferred to the private sector.
In the food industry, alginate is used as an additive in food products such as frozen food, pastries, jellies, ice cream, meat and flavor sauces, beer, fruit juices, and others. It is also used by the paper and textile printing industries.
date, the PPRI has accomplished the following. As we know, sodium alginate is a printing thickener, and it is used to hold the prints in our textile fabrics. If sodium alginate is not present in the printing procedure, we will notice that the textile dye bleeds out of the fabric, and we could not hold the prints in place. So just like as this one, there is a mixing of the colors in the print. But with the proper compounding of the sodium alginate in the printing thickener, we will notice that all the prints in the fabric are held in place. We can distinctly notice the design, and the prints are all sharp and bright. So at present, we have tested the developed sodium alginate of MSI against the imported sodium alginate. We can notice that this is the sodium alginate thickener from MSI. This is the commercial sodium alginate, and this is the laboratory produced PPRI sodium alginate, which was done prior to the MSI thing. So from this shading, we can notice that the performance of the MSI developed sodium alginate with the standard is very comparable. And right now, MSI is producing several alginate products, which we wanted to test both in the laboratory and in the mill application, so that we can somehow recommend to the mill on some alternative sources of their sodium alginate compounds.
Alginates are widely produced in the United States, United Kingdom, Norway and France. Japan, India and Chile also contribute to the world supply of alginates. The Philippines is also a good producer of seaweeds. Not a single firm in the country, however, is engaged in alginate production. According to research, the textile and allied industries account for 50% of the total alginate demand. This Picard-assisted project offers many laudable benefits. 1. The use of Sargassum will be maximized in the production of alginate. 2. There will be an increase in industry and business opportunities, particularly in areas where seaweeds abound. 3. Alginates will be locally and commercially produced to substitute imported ones. 4. There will be a decrease in the country's dollar outflow used in the importation of alginates. Alginate production involves several processes. First, we collect Sargassum seaweeds from our shores. Abundant supply of these can be harvested in shallow waters near the beach. Then, the gathered seaweeds undergo formalin treatment. We dip the seaweeds in formalin solution to cleanse and maintain their freshness. Treated seaweeds are then dried and later placed in sacks. We then soak the seaweeds in a dilute acid solution, after which they are washed or rinsed to rid them of acids. These are then transferred to another tank, where they are soaked in alkali solution for 24 hours. Depending on the chemical content of the alkali solution, we can produce either sodium alginate or ammonium alginate. The seaweeds are then placed in a kettle or soaking tank for disintegration. This tank serves as an oversized blender wherein seaweeds, after several seconds, are reduced to a pulpy mass. Let the pulpy mass settle for a while. Those that float are usually skimmed off. Fine particles, or what we call slurry, are pumped into the filter. This is to separate the solids or coarse seaweeds from the liquid or the filtrate. The filtrate is pumped to the horizontal pipe until it falls into a precipitation tank containing isopropyl alcohol. The filtrate is precipitated and transformed into fibrous cotton-like mass of light brown to white. These are then transferred to another alcohol tank for further dehydration and solidification. The mass is later squeezed dry before placing in drying trays to be further dried in an oven at a predetermined temperature for at least 24 hours. This is then followed by grinding, which completes the process of producing alginates in granular or powdered form. Although alginate production has potentials for techno-transfer and commercialization, Dr. Montaño believes that there is something more in store for rural livelihood in terms of raw material preparation.
Okay, for technology transfer, this I could say that although the process seemed to be simple, but we need a lot of specialized equipment because the product in water solution is going to be very viscous and very thick. So we need a very good, efficient filter. But let me go back to the raw material. The raw material as of the present is not being farmed. They are just collected wildly. They are seasonal. So one has to take care of scheduling when to harvest the seaweed, how to harvest the seaweed. That means you do not take off the holdfast, just cut off from the top. So you have the plant, you still leave the plant to regenerate itself rather than pull out the material and you just degrade the entire Sargassum bed. And also the right type of treatment of the Sargassum, drying and also pre-treatment with some chemicals so that the alginates would not degrade.
The country has huge untapped seaweed resources. Through R&D, Picard helps develop appropriate technologies for seaweed processing. With the formulation of the Science and Technology Agenda for National Development, Picard hopes to attain industrialization in support of the Philippines 2000. Picard, spurring countryside development through the application of R&D and promoting livelihood projects. Seaweed processing, a technology for the Filipino entrepreneur.